Great. Welcome to my talk on Agile Database Techniques. This is the talk that I presented at DevConf, and I thought it would be great to share it with the Durban crowd. Yeah! Awesome. I've had so many people ask me about this talk, whether it was recorded or not recorded, and I'm glad that we are recording this and we can get it out onto the web. There's a fair number of people talking about it. Alright, so anybody that knows my talks knows that I love to share, and I love to share around ideas. Ask me an interesting question, answer a question in my talk. So answer a question, ask a question, beer, tennis ball, beer. These tennis, if you get a ball, please don't squeeze it while I'm talking. It's like uber annoying. Alright, so it's all about sharing, it's all about getting a chance to share, take what we've learned over the last number of years around Agile Database Techniques and share it with you guys. Now this talk has been done before, except it's revamped now with newer tools and some techniques and things that we've learned along the way. So for everybody who may have heard this before, it's fairly new. Now I want to start off my talk by talking about these gentlemen. Does anybody know any one of these gentlemen? I know we're all geeks. Anybody got to know any?
Lance Armstrong?
No. Damn. Lance Armstrong is not. Okay, there's a bit of a hint. These guys are all British. Actually, he's not. He's African, but he has British citizenship.
British cycling team.
It is part of the British cycling team. Sure. Okay, so Sir Bradley Wiggins, Chris Froome, and Jeremy Thomas, these guys are probably a fringe, but there's something that every one of these guys has in common. Does anybody know what they have in common?
Cycling?
Cycling is a given, yes.
Yellow jersey.
They're all wearing yellow jerseys. Alright. And there's a trick about them all wearing yellow jerseys. They're also all, funny enough, right for the Team Sky. That's quite evident here. And they've all contributed to Olympics before. But the other thing that they all have in common is this gentleman here. This is anybody got an idea for a tennis ball?
Coach.
It's like dragging it out. Roy, you don't want a beer? Do you remember?
No, I'm not going to do it.
It's not going to do it. All right. So this is Dave Brailsford. All right. And David here was talking about something that's very unique about his approach to cycling. It's not the size of Donald Trump's hands. It is, in fact, that he took the British cycling team, which hadn't for many years and many decades won any gold medals, so they'd won a few gold medals at the Olympic Games, and he turned them around. At Beijing, he won 7 out of the 10 track cycling gold medals. They repeated that again next Olympics in London, and in this last Olympics they've done exceptionally well. He then took that formula and he applied it to the Sky team, and they won 3 Tour de France on the back of Bradley Wiggins and Chris Froome. All right, there we go. Thing that I asked you not to do. What is it that makes this gentleman quite unique? Well, for a start, he understands cycling. And the other interesting thing is that he has an MBA in which he learned about Kaizen, around making things incrementally better, taking out the waste, cutting out the waste, and cutting out the waste. And he comes up with this concept of the aggregation of marginal gains. And what this means is that over time, if we make small 1% improvements, we will start to see an exponential increase in improvement of whatever it is that we're doing. So if we start making incremental improvements in our build process, if we start making incremental improvements in our code, if we start making incremental improvements in our databases that we're going to talk about today, over time, these small increments actually compound to become quite a large aggregational gain on our system. The converse applies as well. If you leave a system with these declining elements where you don't take care of the database structure, you don't take care of your code quality, you don't take care of your build time, The opposite applies. These small broken windows, for want of a better word, will add to the gradual decline, and it will exponentially decline of your code base, as we all know. And hence the theme of today's talk is to talk around the marginal gains that we can get out of refactoring our databases. All right, so the goals of the talk today are to introduce the concept of database refactoring. This talk is aimed at people who have never done this before. Then to consider some refactoring patterns. So how do we apply certain changes to the system, and what patterns could we consider? While we're considering each one of those patterns, we will consider the marginal gains that we potentially could get out of those patterns, and then there's a suggestion on how do we get started with this technique. All right, so evolving your database and refactoring, and whenever I start talking to teams about this, I get this sort of look about being the most insane person in the room, like I've got 5 horns growing up the top of my head, not just one like this unicorn has right now. And it's actually quite frustrating. So let's talk about how you would evolve your database. Well, in order to evolve something, we need to talk about this concept of refactoring. But before we start looking at refactoring in the database realm, we need to consider it how it differs slightly from refactoring in the code base. Because normal code base, kind of write a unit test, have some code that's been covered by that unit test, and then we find that we don't like what that thing does, or we have to change it because it's doing something in the suboptimal way. So we will change the code, or potentially write a piece of code because it's doing something different, writes a new test, alter the code by some quick refactors, extract a method, I don't know, introduce a variable. It's very simple refactoring techniques. Run the test, it's all sorted, and we ship it off. Database refactoring, unfortunately, is a little bit more tricky, and we have to think about a few more pieces before we can actually get into this style of database refactoring. Right, so the first thing we have to look at is we need to start considering a little bit more of a release process, because the database is kind of an all-pervasive thing. It doesn't sit locally on a machine, and it's probably better to start implementing your changes on your side and make sure that they flow through to a second system, sort of an integration system, and then onto a system where you can actually test them correctly as to how they're going to affect the business processes, because they're almost, it's like there's stuff under the hood that could be going wrong. So we generally introduce some kind of release process when we start looking at database refactoring. We then need to find a tool which is going to manage this release process. Now, the tool could be as simple as, in cases where I haven't had a tool available to me, actually just writing a bash file or a PowerShell script that just runs through a list of scripts and applies them to a database and rolls them back if they have a problem. Or it could be much more complex, and we're going to talk about some of those complex tools. Today I'm going to introduce Switch, and I'm going to introduce Flyway, but those are tools which will manage the release of your database scripts into your environment and manage the process of not rerunning those scripts so that you end up running them more than once, or potentially being able to, in Switch's case, roll it forward and then roll it back without having to worry too much about what effect it's going to have on the data. We also then need to think about database versions. All right, so we've now got to start strapping our data structure, our schema, and potentially some of the data in there to a particular version, and that's important. That would often be dictated by the tool that you use. We're going to start thinking about our file naming conventions, how we're going to name these files so that they actually mean something when people just look at it and start debugging issues in the process. We also need to start putting these changes to our database under source code control, because that's ultimately a really good practice. Not enough DBAs do this. Not enough DBAs or database-focused people spend time taking the source of their database and actually putting it under the source code control. And then we can actually start refactoring. The refactoring process, a little different. We start a script that changes the structure of the database, introduce a column, rename the table, and then we create a script that migrates the data, moves the data from this column to that column, or moves the data from this table to that table, and then we can apply it to our system, validate that it's applied using some form of unit test, or just validating that the structure is what you expect it to be, and then we start the process again of structural change, data migration, apply, test, and we just carry on the cycle until we're ready to release, and then pop through the release cycle, the release process, and get these things out into production. All right, so that's the general process of evolving or refactoring a database. First pattern I want to introduce is script all the changes. If you can, start right from the beginning of your project where you're scripting the creates and the inserts of all your metadata. It's just good practice. Somebody joins your team, here's the scripts, run these scripts, database is up, it's at this particular version that we're working on, and we're actually up and running. If you don't have, if you haven't got into this practice of using refactoring process or refactoring techniques, well, I'm going to give you some suggestions on how to do that. But managing your scripts and keeping them under source code control is good practice, and it allows everybody to have eyes on what we're actually doing. All right. The cool thing about it is it's repeatable. So you can go to anybody's machine, be it a developer's machine, be it an integration machine, be it a QA server. You can repeat the same process that you repeated on your machine on their machine. Right, it's reliable because it's the same process. You don't have to think about anything. You just take the scripts, pull them down from whatever repo or NuGet package or whatever it is that you're doing onto the machine, run the software that applies the things, and we're back on track again. And it's scalable. I don't care if I've got a team of one person or a team of 50 people, this process scales to whatever number you've actually got. Just requires dedication and good practice. All right, so the marginal gain that we get here is that we don't have to think about setting up people's new machines. We need a new server to be able to test this thing. Bob, can you get the scripts? Can you run them? Bob takes 5 minutes, the database is back up again, we're getting rid of it. It's not like, oh, can we get a database from production? How many of us have done that? Bring the database from production, land it in there with all our clients' amazingly cool data, and that's what we're actually going to use. And then somebody goes, hey, I think I'm going to do a test on this account, and when the thing runs, then it's going to send an email, and who does it send the mail to? Sends it to the clients. And so we have this reputational damage we've got to deal with, and we've got all this craziness that we actually have to deal with. Just start putting your databases in scripts. Get them migrated and move them correctly, and we don't have the grind of the team trying to actually just do its job properly. All right. Renaming a table. Okay. This is quite a common one. If you're in an Agile team, so this is one of the patterns that I just wanted to introduce. Sorry, I didn't really talk about where we're going. This is a very common pattern that I actually see out in the real world. We start off with this concept, kind of like blue sky, and we're going to use, let's, for want of a better word, MVP, this darn thing, and we're going to create this table, and it's going to be named, I don't know, legal entity, for example. It means nothing, it's pretty nebulous, and we're just going to carry on working. And at some point in your development, somebody goes, this thing, legal entity, like, what does it mean? It doesn't carry any domain meaning, it doesn't have any real language that I can attribute to it. Why don't we change the name to customer? Because it's friendly and I understand what I'm dealing with when I get to customer. So we're starting to unpack the domain and understand it a little bit better. And so this is a fairly common practice in Agile Database Techniques, is to rename the tables that probably don't mean a hell of a lot to us as we're working. All right. So what I wanted to start doing was actually going through the refactor process on the command line, showing you exactly what I would do to refactor the table name, legal entity to customer, using Switch as a database tool. Now, Switch is an open source database management tool. The only downside for you Microsoft zealots is that it doesn't run on a Microsoft tool. So you'll see this is a Postgres implementation. I'll walk it through. But follow it. Let's see if somebody writes the plugin that runs Switch on a sort of SQL database. It can run in Windows, but it doesn't run on Windows type databases. Right, so Switch is quite interesting in that it actually has a file that it keeps all the changes inside it in a chronological history. So as you go switch add, and this is sort of a tag of what you're doing. You give it an actual real name. Oh, actually no, this is the file name. What you're going to do, you go switch add, and that's the rename legal entity to customer, -n, which would be the name of what you're actually putting in. Switch goes in, creates a directory structure for you to put apply and roll back and test-based scripts in place, and then creates a registry of these items. And you're welcome to go into that registry and move them around if you feel like one needs to come before the other, but that's essentially, it's a text file that they manage the database changes in. All right, so the first entry that Switch will put in for us is it will create a deploy directory, and inside that it will create a file name called deploy directory, rename legal entity to customer. And I will then go in and write my SQL statement to be able to rename my legal entity to customer. Now, there's two ways in which you could potentially do this. You can do it this way, where you just do an alter, because you know it's an existing table. I find that this is a little bit dangerous, and so I opt for this more belts and braces style of doing my scripts, where I allow them to be idempotent, so I can run it as many times as I like without affecting my data structure too much. And so there we go. The idempotent part of this would be to say, if it exists, then do the alter, otherwise don't bother about it. And so that would be the forward movement of my database using Switch. All right, Switch also creates an entry here for revert. Right, so this is to undo the change that I potentially could have done. Right, and you can see alter customer name, rename to legal entity. So that's to do the reverse of what you've done, and we do an idempotent version of that. So you can do either one, and we put it inside this file named rename legal entity customer inside the revert directory. And then it's got an item to be able to verify. You could put some form of test in here in terms of an actual unit type test, or you can just do a test that verifies that I'm able to access that particular table and do something on it. And so this is the deploy, roll forward, and I can verify that the changes have actually been made, and then roll back from position from where we are. And so this is the roll forward, roll back mechanism. Right, and so when we get our database up to date, we go switch deploy, runs through all the scripts that I've got, puts them into deploy, switch verify, goes and runs all these little verifies, and checks to see that the changes have actually been applied correctly. And then if I really wanted to, I can move my database back to the head of where I was before I actually tagged, because we've got quite an interesting tagging technique in there. And you say switch revert to head, and it will go and run all of these revert scripts to undo my database and actually walk it through. All right, so we've got, I would believe, a very powerful tool in Switch on database management. All right, so the marginal gain that I get out of this is more to do with the domain language and the confusion that I often find people have around domain language. Somebody who joins the team, now they've got to learn all of these crazy domain rules, like what is a legal entity, like what is a juristic entity, what is an actual person. And like if you're in the space and you understand it and you've learned the domain over a while, then it's fine. But often these types of terms can actually hamper the way that we're developing, especially around the language that we use. And so it might be easier to move to customer. Stops the confusion, stops all the craziness. And so even at a database level, we're able to communicate correctly and get a marginal gain through our system. All right. Well, you'll say to me, oh, Chris, but that's really cool. You're going to write this simple little desktop, this little application. It's very small, it's not very complicated. It's some MVP that you're doing for some guy who's got some idea, or some lady who's got some idea. That's all very well, but I work on enterprise database systems. So how do I do a refactor using that technique? And the answer is, well, we can actually just encapsulate that table in a mechanism that makes it look like a table. Has anybody got an idea? For a tennis ball, Mark?
View.
A view. Well played. Except I didn't catch it. A view is a very good way to encapsulate what a database table is actually doing. Bad Mark. Squeaky squeak. No. Anyway, all right. There's another way to do it. It's stored procedures. It's another way to encapsulate functionality inside a database. But we're going to look at how do we encapsulate the database functionality inside a view. And in this tool, I'm going to use Flyway, which is another open source tool, but it runs on a variety of different database platforms, including SQL. So I'm going to run MS SQL in this particular case. Flyway doesn't apply the principle of moving forward and then being able to revert. It actually just moves forward in a logical pattern, and it uses file naming conventions to work out what versions to apply and the order in which it's actually going to apply those. And so it's actually a little bit more loose and lightweight in terms of the rigor around managing it. All right, so the first thing that we would need to start is create a database migration script, telling it that this is the version that we're going to, and potentially have a bit of a date so we can get a chronological order of these things happening, and then a little bit of a description as to what we want to call that particular script so that it's easy on the eye when somebody's actually reading it. This is where I talked about database versioning being important in the very first parts of the script, where we talked about choosing a naming convention and also choosing a file naming convention, because as you can see, it also dictates on how you're going to apply them and what order they're going to apply in. All right, so the very first thing is, you can see I'm working on my big banking app. That's the database that I'm using. All right, so it's a huge database for some bank, and it's got lots of client data in it. So to read the data out the table is relatively simple. We create this view, create a view called customer, and we select ID entity name from legal entity, and we're done. It's easy to view it. But most of you guys may not have known that on a view, we can actually create a trigger on the view. All right? And just say that we create a trigger on that particular view, and instead of doing an insert, we will go in and do this, and now we've abstracted the logic away from ourselves, and we can actually just allow somebody to use this view as a table. Right, so that's to do the insert. The updates is in exactly the same way. Instead of update, we would do the update, and instead of a delete, we would do a delete. And those would be the scripts that we would include inside this table. Notice there's no migration or any complexity that I've got inside the system. I can actually just create this layer of abstraction that kind of protects me a little bit. Now, the problem with these things is that there are triggers, and we have to remember them, and we have to manage and maintain them. I'm not a huge fan of triggers. They've got their problems associated with them. But this pattern does come in handy when we want to be able to refactor a database, and we can't get to just touch that table, because I can guarantee if I touch legal entity in some of the bigger clients that I'm working on, it's probably going to break their system overnight, quickly, just like rename the table to customer, and I think every report would break. So that would be the problem. All right, so with Flyway, we would just do Flyway migrate, and it would know where to, well, you configure this. There's some basic configuration which I'm going to gloss over because it's easy to read that in the user's notes. And Flyway migrate would go and run all the different scripts. Once it's run, you do Flyway validate, and the validate is really just a simple process of it knowing that it's actually run this database. So it keeps a sort of a log history of what it's run on your database or not. So it actually creates a table inside the database, has all the different versions that it's applied, and it knows how to move from one to the other. It's a very common technique of managing the scripts and the order in which they're run, to keep them in a table inside your local database. Right. So we have a marginal gain here, where we're able to still use this domain language that's more expressive and more rich, and we can potentially, even if it's not domain language we're after, in certain cases we've used this technique where we've got to bring concepts and encapsulate them into more than one table. And so we start getting one common concept that is going to introduce data into many different tables, which we don't want the users to be able to know about. And so we've abstracted some of the complexity away from the actual code base. All right. This is a fairly trivial refactor, which is the move column refactor, which you will see quite often. You don't like a column on this table. You started off with a system that had customer and account, and over time you realize that the balance for the customer shouldn't really live on the customer record. It kind of started there because it made sense when we were doing it, but over time we created this concept of an account, and we probably need to move this balance across from the customer onto the account. The reason why I wanted to bring this in is because I wanted to talk about the technique of doing this when you've got more than one system looking at your data. So you've got a database on this side, and you've got a service on this side, and a service on this side. And it's actually they're both using the data, and now you want to be able to move them. This one you can move quickly, and this one the team's backlog. They've got a lot of work to be able to do, and so you've got to refactor a lot slower. And how do we manage this move? Well, we start off with this scenario that we've got here. We've got the customer with the balance record on here, and we've got this account, and we decide, well, we've got to move it over. But it's going to take 6 months for these guys to move over, and we can move over straight away. So we introduced the balance column on the account side as well. And then we create a trigger that's actually going to keep feeding the balance value back into this side and potentially feed it back onto that side again. So we're actually keeping this data in check with triggers. And over time, these guys make their change to their system, and we can then remove the column from this side and keep it on that side, and remove the trigger, and now both systems are actually in sync. So the trick here is to use the techniques of moving data from one point to the other, in this case a trigger, to keep the data synchronized for this long period of time while we make these database refactors. And then once we're all happy that this system can go live, pull the balance off of this side, take the trigger away, and now the database is actually in sync. So what would we do? We would start the migration. We would start by migrating the structure. And so we would alter the table to add balance. So we add the balance table column at this point over here. We would need to migrate some of our data. So we would write a migration script to get the balance from this point to that point, so that they're in there. Then we would need to create the trigger. So here's the trigger that keeps the items in sync. And then those systems would run for 6, 7, 8 months, a year. I don't really know. And then at the end of the life cycle, we will drop the balance column and then drop the trigger, and now we've got this ability to refactor over time. All right. The marginal gain that we get here is that we can introduce columns and move them across and not affect these teams. All right. Wanted to talk one last pattern, and then we're pretty much done. Split a table. I've seen this a couple of times, and I just thought it would be interesting to come to this talk not with any introductory concepts, but to talk about maybe a bit more complicated topic. So just out of interest, and something that we picked up as we were going, we had this the system where there's a large amount of data in this employee table. We have this 47 columns, and if you go and do the SQL mathematics behind this, how much disk space can one row take up, and what happens if you only fill half of that row, and there's a whole lot of discussion around that. What we end up having is this particular employee table with 47 columns and 6 bytes per row, which is way over the sort of magic number of a row that SQL can hold. We end up with a sort of 12 gig memory space. But if we do the calculation where we say, well, if we take the employee's personal information and we only keep 14 columns of that, and we have only 1,000 bytes per row, we can put 8 rows, because it's about an 8K page size. We can put 8 rows on, and all of a sudden we've got 200 pages and only 1.6 gigs And if we did the professional information, we could do exactly the same concept and we're going down to 2.5 gigs. And if we did the employees' miscellaneous information, so this might hold large quantities of things that we didn't really care about, photographs and all kinds of other things. But if it had 17 columns, we had 4 bytes per page, 4 rows per page, we could get 3.2 gigs. And I don't know if anybody is going to be a super whiz calculator in the room. That works out to about, what, 7.3 gigs. And so the refactor here is that we're actually taking what is a very large complex data structure and breaking it, a very large sort of table structure, where we're wasting a huge amount of disk space because we can only write 1 row per page. We've got this 3,400 bytes of wasted space. We can now store that stuff on disk in 12.8 gigs. The real interesting thing is anybody got any view on what that 12.8 gigs looks like in the actual memory of the server? If I had to read the entire employee database into memory, then I would really just be loading all of that stuff actually into physical memory. So what we've got to remember is that as you're working with tables where you're reading a large amount of stuff, let's say I read 1 row, 1 employee's record in, I'm going to read 4.6K, and because of the row size and because of how we do memory management in SQL, we're going to waste that space. And so we've got a suboptimal process, or suboptimal way of saving stuff on disk. Suboptimal saving on disk leads to a suboptimal saving in memory. And then what is the DBA's usual process around solving these problems? They put more memory in the machine. Well, that's not the solution to the problem, because all we're going to do is we're just going to try and scale and scale and scale and scale until we can't do that anymore. The better solution to this particular problem is to refactor the database so that we get to use, if we're using this data a lot, well, then we're only going to be bringing a smaller amount into memory, and we can load 8 rows of that information into memory. And the fact is, if we had all of this stuff that we wanted to load into memory, it would be pretty much half or 40% of the space that we would have used there. So that's I found this quite an interesting thing, so I thought I'd share it with you. So how do we do the split pattern? All right, well, we created 3 tables: employee personal, employee professional, employee miscellaneous. All right, so we have these 3 tables. We migrate the data. We migrate this data here to there. We migrate the professional information from here to there, and the miscellaneous information from down here to down there. And so when we want to know about the employee's name, we don't get his shirt size, for example, or something equally as arbitrary that we don't potentially need to waste up that memory. And once we're done, drop the table, and we're ready. So that's a refactor for a problem which is really a disk space problem, but would ultimately lead to memory problems further down the line. And that's the marginal gain that we would get from this particular refactor, is we're now actually affecting our DevOps people in a positive way by thinking about what we're actually doing and making those marginal gains and where we're going. All right. So how do I get started? That's the question that most people will probably be asking. First thing is baseline your database. So if you've got an existing database, the easiest way is to just baseline it. You've got a large number of tools, Redgate, Apex, there's a number of tools that just look at a database, and you can say, I want to get this particular schema, dump it down, and I want all of these tables and their data. If you're on Postgres, it's even easier. There's a lot of command line tools to do it. As you go in the open source environments, I find it easier to baseline my database rather than having to shell out a lot of money. But baseline your database, decide on your tooling, decide on your versioning, your file naming strategy, and then manage your scripts under source code control, because your devs will love you from that point onwards. Then implement your release process and start refactoring. So the question I have for you guys today, are you going to join me in this refactoring greatness, or are you going to stay the aggregate?
We really have to. We get a tennis ball.
Yes. Thank you very much, guys.
Go.